the center of rotation of your tomography dataset. And in the tutorial, we're going to first discuss about why you need to use the center of rotation. Then also the principle about finding the center. And there are a lot of algorithms doing it, but it's also good to know how to do it manually. And finally, I'm going to round off with sample tilt. And the center rotation is, in tomography, you rotate the sample and you can see that you get projections with different views. And all projections, they are rotating around a virtual point in the image. This is the point we need to know in order to reconstruct data. And the principle for finding the centrum is that you take two projections on opposite side of the object. So one at 0 degrees and one at 180 degrees. Then you flip or mirror one of the images. In this case, I did the 180 degrees. And you slide the two images until they perfectly match each other. And the displacement you have to do is the one that you need to adjust the center of rotation relative to the half of the image size. So this is the basic principle. There are algorithms doing this based on, for example, correlation, center of gravity, and things like that. But right now we just look at the visual version of it. And sometimes when you do this, you may not really exactly hit the perfect center. And then you get artifacts looking like this. And you can see that there is a skip here. And this gives you some kind of tail effects. And those you need to get rid of. And also, depending on how well you fix your center, it can actually give some blurring effect if you're not perfect. So you can actually fit the center in sub-pixel level and still see differences if you have a sharp image. So you can also identify different images. And so if you have the half turn, you can even see in which direction your center must be moving. So in this case, I have done on the half turn, I have done -8 pixels, I have done 0 pixels, and I have done 8 pixels displacement of the center. You can see here that these tails, they're pointing downwards or they're pointing upwards. So that gives you an indication in which direction you have to move. If you do a full turn scan, which we do very much, at least at PSI, then you can see that there is no difference between minus and plus 8 pixels. You only have this ring around the object, and that is leaves you to only guess which direction. So you have to do a little bit adjustment minus, a little bit adjustment plus, and see which gets better. And then you have to tune in until you find the perfect center. The last thing that we also are going to look at is the tilt of the acquisition axis. So ideally, you should have the rotation axis perfectly aligned with the pixels in the detector. So what normally is done is that you align the table with the water level, and also with a perfectly vertical line on the detector. You try to rotate the camera in order to get as parallel as possible. With these measures, you can usually land somewhere below sub-degree accuracy. But there is usually a little bit of error in it still. So say 0.1, 0.2 degrees. It can always happen. Doesn't sound like much, but the effect is that you can get different reconstructions depending on which slice you're reconstructing. So you can see here 3 examples. The perfect case is that all The axis is perfectly aligned, and you can see that the blue and the green slice, they are perfectly reconstructed. You can also have the case that the sample is standing tilted on the detector board, but that's no problem, because then it will rotate in a way that lets you reconstruct it. The cross sections you reconstruct, they will be elliptic, but that doesn't matter because you still have a sharp reconstruction. The worst case is when the sample table is tilted, and then you can tune as much as you like on a single slice. It's perfect. But if you move like 100 slices up or down, then all of a sudden you have the ring of uncertainty like you had if it was off center. So that needs to be corrected, and I'm going to show you how to do that soon. And now let's move over to Murex. We already showed it a couple of times, and you can see here is the center line that was reconstructed or estimated in a previous tutorial. This one actually does a pretty good job already. So if you just reconstruct it, so pressing start reconstruction, you will see that this is a nice reconstruction. I can even move to a different place, like up on 200 till 232 and reconstruct again. Now I used a shortcut to start, so that's Control R on Windows and Command R on Mac. So now you can see that I moved up 300 slices and it still looks pretty good. So that's fine. Now, if we go the manual way, it could be that this center estimate that you can do with help of Murex is not really ideal. Then you need to do something manually. So let's say we guessed that we were around 270, we don't have any tilt correction, and let's reconstruct this. And you can see that we have a very broad uncertainty region here. This data was captured with 360 degrees, so you can see that there are no tails around. So now we have to move a little bit in with our center. So let's just do a little guesswork. So now we do to go to 275 and reconstruct again. And see, yeah, it turned out pretty good. And the trick here is that you can actually measure how much you need to move. So let's go back to 270, just because it's much clearer. So what you can see here, you have the tooltip tells you the position that you're working at. So let's take a position here on the outer edge of this uncertainty region. We see that we are at 79. Then you can move over here and you see that you have about 98. So we have approximately 20 pixels between the outer and the inner edge here. If you divide that by 2, then you have the step you need to move. So now we know that we have to go plus, because we already did that test. And I'm adding 10 to the 260, and let's reconstruct and see what we get. And it's pretty sharp already. Now when the sharpness is at this level, it may be difficult to tell if it's going to get sharp or not. So then we have to actually do a little bit fine tuning. So trying ±1 pixel and reconstruct again. So as you can see, there is a lot of intermediate reconstructions, and this one didn't turn out pretty good. So let's go back again. Maybe we do 79 instead and see what happens. Yeah, actually, I think it's actually better. And now it's very subjective if it's good or bad. So what we have is this geometry. Then you can do store geometry, and you can go back here to 80 and do a reconstruction again. and we store geometry, and then you can go into view geometry list and you can compare the two of them. So you can see this one was done at 279 and this one was done at 280. And you can see that there is actually, for 1 pixel shift, there is already a remarkable difference in sharpness. So it's really important when you tune your reconstruction that you really pay attention to getting a little bit better all the time. We could even go one step further, doing maybe 78 and try what happens then. And we store geometry, go into the geometry list again. And now we know that the 280 wasn't really relevant. And we can look at 78 and compare it to, the visual difference is not very big in this case. So maybe we should settle with one of those, or maybe even take the middle of them. So let's take 278.5 as our final center estimate. And then we have something that we are happy with. Now, if we use this, as you see here, I didn't have any axis tilt correction yet. If we now do this reconstruction down at something like, let's say 700. Now we should save this geometry store. So let's go down to 700. Oops. And 732. And reconstruct again. And you can see, this wasn't good at all. So now we have to repeat this procedure again. And let's look for the point here. We have 120 and going to 128 maybe. So let's say we have a 4 pixel shift. Now, again, as it's 360 degree, we have to guess. And I would guess now, let's go to 82.82 and reconstruct and see what we get. It turned out pretty good. So now I'm not going to repeat the whole iteration of refining, but just saving this one. So let's do store geometry. And now we have actually 2 center of rotations in our reconstruction. And there is a straight line relationship between them. And with the help of the geometry list, you can select, let's see where we have them. Yeah, we have to take those two. I didn't save it apparently. So let's take the one at slice 200, which was 278, and the one at slice 700, which was at 282. And now we have the button here, compute tilt, and it computes the tilt for us and says also that if you use this tilt, then you have a new center of rotation. You have a tilt of 0.45 degrees. And then we press OK. Going back here, you can see that the correct. Then you have the new center of rotation, you have the angle, and you have the pivot point. And now let's reconstruct and see, just for checking, because we always have to check that it's good result. And at 700, still looks pretty reasonable. Let's go back to 200 and 232 and reconstruct again. This looks, well, maybe not perfect. So maybe we would have to do some additional adjustments to get it right. I didn't do that thorough center correction for the 700 slice, so maybe we would have to do some refinement. So the whole finding center rotation is a long iterative process, and it's important that you pay attention to it. That's the take-home message for this tutorial. And that's also the end of this tutorial. Thank you.